I think we can probably get started.
I think we can get started. Hello, everyone. My name is Johan.
I'm Chris.
We work at Google. We want to talk about the Storage Access API today and how it's improving the cookie security model, and a bunch of other technologies that we're building as part of it, like storage access headers. And happy to do a bit of Q&A on that. So who are we? We work on the Privacy Sandbox at Google. That means we work on Chrome and the web platform. And our mission is to improve web privacy and security. Right, so let's talk about third-party cookies. Some things, just recapping some things that all of you might know. Third-party cookies can be used for tracking users browsing online, right? So you can embed tracking pixels and all that, and just the fact that they get these cookies, these credentials sent alongside the request will allow a tracker to understand whether they have seen that user before. They may have some information about, the site that the user is visiting that's making that request, and so they can build a profile of that user by passively being embedded on the page, for example. For that reason, a lot of browsers decided to block them by default. So Safari, Firefox, Brave, and Edge has like a partial blockage of third-party cookies based on a block list, if I remember correctly. So that's a bit of context for that. Next slide, please. What some people may know, others may not know, is that third-party cookies are not just used for online tracking. They're also used for a bunch of the web platform features, such as cross-site embeds, widgets. If you with like comment widgets, if you want to do like online appointment booking, it's very often like these what we call authenticated embeds, calendar widgets, and all this stuff. And then there's like single sign-on functionality, such as single sign-out, or some like these token mechanisms that are used in single sign-on, like token refresh mechanisms that are currently and were in the past relying on third-party cookies. So there is a pretty decent reason, and like a lot of reasons, for us to keep them around on the web, but we have to make sure somehow that they don't impact user privacy. Thanks. So the thing that people originally thought of when I say people, I mean Safari, Firefox, and Edge originally in 2020, is the Storage Access API. The Storage Access API, it has two functions that it exposes, two methods on document called request storage access and has storage access. And essentially, the Storage Access API gives people a way to prompt for, gives browsers a way to prompt for access to third-party cookies when the developer calls that API, and will return to the developer whether that prompt was successful, the user allowed the access, and then the developer can use third-party cookies. Of course, that is, I hope that was a relatively simple definition, right? You call the API, you get the permission prompt, you get access to third-party cookies. There's a lot of really complicated details underneath that, right? Like, what does access to third-party cookies actually mean? Why is it called storage access when it gives you access to third-party cookies? All that, right? So there's a lot of complexity here. Can you go to the next slide? So the model that people arrived around at, different browser vendors in discussion, and the spec that we had around 2023 had made a bunch of compromises, and I think the most important ones are first the per page model, right? So if you have one iframe that calls this API to unlock third-party cookie access for it, then that automatically propagates to all the resources on the site, right? So you have, say, two iframes embedded on the same page, and they both want to use third-party cookies. If one iframe calls the API, then the other automatically has iframe. Has third-party cookies. That's pretty good, from the perspective of the people who built it at the time. Same goes for, say, other images from the same site that are embedded on that same top-level page. And the next aspect is it was just cookie access that was spec'd out. Storage access was sort of left unsolved. Firefox had an implementation of storage access where they had essentially what they called like a storage principal, where underneath, their security concept, which is called principal, it had they could like switch it out and change it to a different different principle for identifying like which like if the site was partitioned or not. So essentially, they could say, you call the API, and then under your feet, we'll just switch out the storage mechanism. And Safari had concerns about that, and I think they were pretty well justified in both developer ergonomics, and also just I think they were concerned around. They think they had crashes essentially trying to like swap storage underneath, while it was in flight essentially. And they're like things like storage. I think you have like notifications of service and all that are just difficult to manage at that point. And so that was kind of left unsolved, and just people hadn't figured it out. And then there are various browser-specific rules to avoid the spamminess of prompts, right? So you have permission prompts, and theoretically, third-party cookies are a pretty high-value target, right? Like you want to be able to target people with, personalized advertising and all that. So if everyone just started spamming these prompts, that would be bad for the web. And so, there were a bunch of restrictions put in place, both in the sense that both actual restrictions, right? So you couldn't request storage access unless you followed specific requirements, such as having a prior user interaction, like a prior visit to your page in a top-level context, and also certain rules that made it easier to get a grant so that the prompt wasn't shown. Right? So Firefox, for example, would grant the first 5 requests that were made to this API without actually checking. Right? It was just like, okay, well, first 5 times you call this API, you just get it, right? Because that's like our limit. Like we don't really that's not massive online tracking, right? We're just going to give it to you. And yeah, sorry, next slide. And yeah, now Chris, I think we'll walk you through what we did on Chromium.
So this is where Privacy Sandbox came in and started evaluating the use cases that relied on third-party cookies, in particular the authenticated embeds use case, and the new APIs that we were designing to solve all those use cases. And as part of that, we looked at the storage access API and started to look at like how much does this solve the problem? What problems does it create? Should we implement this, or should we use the implementation that Chromium already has of this, or should we do something else? Should we improve it? Those sorts of questions. We did find a couple of things that we wanted to improve. So Johan alluded to these a minute ago. The first was security. So the per page model is a bit insecure. If an iframe is just minding its own business and some other iframe on that page chose to use this API, and that has consequences for everything else on the page that belongs to that site. The second thing that we wanted to change was we wanted to add support for non-cookie storage. There's no reason fundamentally, for privacy anyway, that should force somebody to force a site developer to use cookies which are sent over the network, when something like a local storage or IndexedDB would be just fine, and even better since it's not sent over the network. And finally, the permission prompts that Safari and Firefox did show sometimes might not be ideal in all the situations, so for every use case. So we thought that we could improve the UX, or had some ideas about how to improve the UX here. So for the first, this was tackling the per page model. So the problem with this, as I said a minute ago, is if you have 2 kind of sibling iframes that belong to the same site, in this diagram it's c.com, the green iframes, one of them can call the storage access API, request storage access, and get cookie access if the user accepts the prompt. But that means that the other c.com iframe also got access. And that iframe might be under attack by some other intermediate iframe from b.com. So this enables things like cross-site request forgery, CSRF, just using the use of this API for kind of innocent bystander iframes. And this is unfortunate because blocking third-party cookies is actually the best thing that we can do to stop CSRF attacks. It removes the ambient authority that CSRF depends on. But this API, as it was originally designed, just immediately brought it right back. So we wanted to change that. So the idea is to change it from a per page model to a per frame model, so that each iframe that wants to access its cookies or whatever has to call request storage access individually. So one frame's activity doesn't affect any other frame. So in this example, again, the c.com iframe that's requesting storage access can get it, but that activity doesn't mean that the other c.com iframe that's embedded in B gets access to its cookies and starts attaching those to all of its network requests. The one nuance that I wanted to point out here is about so-called ABA embeds. So this is the same scenario as before, where it's like A.com at the top level, then a B.com iframe, but then instead of a C.com iframe as the innermost one, it's back to A.com. And this is worth thinking about specifically because there's no privacy boundary between the two A.com iframes, but there is a security boundary. We want to protect the innermost A.com iframe from accessing its the ambient authority that it has from its unpartitioned cookies, unless it actually requests to access those. And this is a nice thing that falls out of the per frame design, is that we can block that access until the API is invoked.
Yeah, I want to add that ABA is such a typical, it's such a common problem in web security when we talk about anything, right? Like I feel like the majority of time actually is spent on like these, because the rest of the problem space is much easier, right? Like an ABA is just such a hard edge case, right? So it's something that we spend a lot of time on.
Yeah, and this edge case comes up, it still comes up all the time. Like, I think it's a weekly occurrence that I say like, oh, and the weird case here is ABA embeds because blah, blah, blah. Okay, so that solves the security problem, but it creates some more problems on its own. So the reason why the original design for Storage Access API used a per page model was because it was more ergonomic. It allowed more use cases to work, and reverting back to a per frame model from that is better for security, but it breaks things. So now, for example, an image that's cross-site but embedded in some other top-level site has no way of attaching cookies to the fetch. So if it's an access-controlled image, it just can't work. So our question was, well, how do we fix that without sacrificing security? This is where storage access headers comes in. The high-level idea is just that we can give a request header and a response header. The request header will convey some metadata about the storage access level of the context that's issuing the fetch. It'll either be like, this doesn't have access, or it does have access, or something in between, like it has the permission granted, but it hasn't invoked the API to actually activate that access yet. And the response header that sites can use provides a way to say, I could service this request that you just sent me, but I need cookies in order to do it. I need the unpartitioned cookies. So you just told me that you have the permission granted by the user already. I would like to activate that permission and retry the request. So this involves a network round trip, but it doesn't sacrifice security, because the origin that owns that resource is still the one that's opting into activating the permission that was granted by the user. Okay, the second problem, if we rewind a little bit, the first was security. The second was it just gave access to cookies. The second thing that we can do is we can give it, or give a way to access all other kinds of storage. So this means that you can pass an object to the request storage access method that just says, what kinds of storage backends do you want access to? and you get back this storage handle that has a whole bunch of members on it that provide all the familiar APIs that correspond to the storages that you just got access to. The all up there, all browser storage has an asterisk because service workers, I think, is the only exception, if I remember correctly. Service workers had some security issues that I think we wouldn't be able to work around some timing attack if we gave access to unpartitioned service workers this way, or at least we haven't found a good way of doing that without regressing security. But all of the other APIs like web locks, I think, like broadcast channel, even things that don't feel like storage, but they're still kind of a way to convey unpartitioned state, those are all accessible through this storage handle.
Yeah, anything that's partitioned, right? That's partitioned.
Right, anything that was affected by the storage partitioning project.
Should be available through this.
Yeah. Okay, and the third thing was the UX. So Chrome is doing a combination of a few things here. We have implemented our own permission prompt, which does look somewhat similar to the prompts that you might see on Safari or Firefox. But that's not the only way that you can get the request storage access call to resolve. You can also use federated credentials with this. So if you saw Sam Goto's talk a few minutes ago, you can use FedCM to connect to the RP and the IDP that way. And then our observation was, well, you're getting access to this federated identity token that's already a high entropy user identifier effectively. There's no reason for us to say that's fundamentally different from a cookie. So we can look at the FedCM connections that have been made or granted by the user and use those to allow access to other kinds of storage as well. The third thing that we do is we have related website sets. And this allows site developers to convey to the browser, this is the set of sites that want to be able to share storage, and I can guarantee to you that the access will not go outside of that set. So Chrome uses this to have a browser validated way of confining how the information is traveling in the browser. I think that's,
yeah.
I'll hand it back to Johan.
Good to be here. Thanks, Chris. Right, and I think the thing that really came out of this work for us is how it shaped how we think about SAA as a platform primitive and like split, right? Like in two different ways, right? Like one way we want to look at the user experience, and in the other way we want to look at the developer APIs. And it's, I think, looking at it from these two sides is very useful because they have, we have different goals there, right? For the user experience, what we want is, of course, we want to preserve user privacy, right? Like we always want to have some sort of gates and barrier that making sure that users are, they have a choice and they're correctly informed, and user agents can sort of like ensure that there's no, cross-site tracking going on. And we also want to be able to innovate on better prompt experiences or no prompt experiences, right? Just ways that users can give websites these capabilities in the least sort of intrusive and annoying way. And on the developer side, right, like we want storage access to be this really stable API surface for continuing to use cross-site cookies and storage, right? We're doing a lot of deprecations, we're doing a lot of work that, just changes things up for developers and makes their lives harder. So I think developing this sort of really stable and ever improving, as the second point hints at, right, sort of API surface, hopefully buys us some credibility, in delivering like something that the developers can rely on. And the other really big bit for us is designing an API that can be used for cross-site cookie access everywhere, and by that defeating cross-site request forgery and other cross-site attacks, right? So having these huge security wins, right? Like as we laid out, like if you use our APIs, then any cookie access needs to be explicitly allowed by the third party that's being accessed. There's no like page-wide access anymore or anything like that. and that effectively defeats these attacks in most avenues. There's still some edge cases around, like say, top level, opening new top level tabs and all that, but that's a lot harder for an attacker to do. So there would be like a huge gain there if we were able to make this just the default access mode for accessing third-party cookies. Yeah. And then we have some, so these are just some things that are upcoming. I think hopefully there's going to be even more, but these are just some things that we have in the pipeline. Chris mentioned how storage access headers has like additional round trips needed, right? So we're kind of, working our way through the different trade-offs that we're making, trying to eliminate one after the other. Specifically for that trade-off, we're looking at a technology called sticky storage access headers, which essentially allows storage access headers users to say, after the first SAH a request, okay, well, from now on, skip these additional, cross-site network round trips because I am confident in my security posture, and I make the choice to be essentially not prompted, or like as a third-party developer isn't asked whether they want to open up to that request or not. They just choose it to like have it on that document by default. And the other bit is an API called Request Storage Access 4, which already exists and is usable just with RWS, but we're trying to get it to be more aligned with the storage access permission model, potentially being able to show a prompt there, and just, overall just fit in better with storage access, because currently it uses a different permission, which is not, I think, like, is not super optimal for developers. Yeah, so if you want to take a couple things away from this rather long and technical talk, so I think the most important thing is sending unsolicited credential requests can be a security issue, right? If you make a third-party request to something, sometimes can even be a browser-initiated request, right? It doesn't have to be literally a resource embedded on the page. But if you have any way for a developer to trigger a network request to another site, making that credential by default is very likely a security issue, right? You probably have problems there. It's very likely someone has a server out there that will take these cookies or whatever is attached there at face value, try to make changes based on it, and if that can be triggered from not themselves, like not this specific server that's receiving these cookies, that that can then be abused. So then in those cases, please try to use SAH, or sometimes CORS is also helpful, though not always, because CORS doesn't really prevent the sending of the credentials, just reading the return value. So yeah, please keep that in mind. New storage types. If you are ever adding a new storage type, which doesn't happen every day, but sometimes it does, make it available cross-site via the storage access handle, right? So please try to think of that. And then this probably happens the least often and is a bit of a long shot. But if you are gating cross-site user identity on a new prompt, you could integrate with SAA, and then the developers you're targeting will get all the benefits that they are used to having, like all the flexibility of building like on established platform APIs like storage and cookies for free, right? But yeah, that's again probably something that not everyone here does. Okay,
and
I think that's the last slide.
That's our last slide. So I think we have a few minutes for questions. I'm not sure when this is supposed to end.
I think it's half an hour, so we have 5 minutes.
5 minutes.
Anyone wants to? Good.
For sticky storage access headers and the has storage access API request, is there an expiry upon which users will be reprompted to grant access to third-party sites again?
So the sticky storage access headers thing doesn't have any effect on the permission that the user has granted. That permission is still going to have a lifetime of 30 days or longer, depending on the user's interaction patterns. The stickiness is per document, to say like this document is allowed to issue these credentialed requests because the server already told it it's allowed to do that.
Okay.
So each individual document would have to invoke this new mechanism separately, but it would be around for the lifetime of the document.
Okay.
The retry mechanism looks an awful lot like critical client hints, and I know there's been some past effort to potentially move some of that into the TLS handshake. I don't know if it makes sense here because maybe it's not for the entire connection where you want to tell it to retry. But general question is, have you got any developer feedback that, hey, this retry is painful, and can we reduce them?
That's a good question. That is the main impetus for doing the sticky SAH optimization. I haven't looked into TLS handshakes as another optimization opportunity, but that would be interesting to learn more about.
Yeah, we should think about that.
Yeah, I think Ari knows stuff about that. We can ask them.
Maybe?
It's under client hints reliability if you're trying to figure out.
Okay, we should take a look at that. Yeah. But as you said, like, there's definitely been feedback from the developers that we've been working with on, this is, we want to, we don't want to have the overhead of, every single request on our page. Like, what if we have like 20 or 30 or 50 requests, credential resources, and they all have to send this header and like all have to do the round trip. So this is definitely something we want to look into.
And it would be sticky to the origin level, or what's the scoping of stickiness?
Like, working with our security team, they were like, can we make it even more restricted? So I think we kind of want to put it at is it like even the path level, like the URL path level?
I think we landed at that.
But you can specify. There's like the header, like the retry header allows you to like say, I think, how much of the path you want to expose. So I think you can make it origin.
Yeah, I do believe there's like a full path wildcard. So
if you have that, then forget the other thing I say, and that doesn't really.
Okay. Yeah.
How's the related websites list populated, and is any validation done?
All of the validation is done on GitHub, so that's
Open source.
Yeah. Yep. You can just browse the source code there. We do pull it into the internal Google repository and revalidate it before we ship it out via a component updater.
And then can anybody push their related websites to the GitHub if I
can
the web dev?
Submit it, and it, like after it passes the automatic checks, it's likely going to be it's like the processes that is just merged, right? There are some very exceptional cases where someone makes a weird mistake and it's not, but like the regular process would be that it's merged after passing the automatic checks. Yeah.
Okay, makes sense.
So I didn't hear the word shared storage.
Shared storage isn't.
This is unrelated.
This is separate. Yeah.
Shared storage is like a mechanism that is mostly used with fence frames, right? So it has an output gate. Like the idea is you have shared storage and then you have output gates, right? So you can put stuff, you can write stuff into shared storage, but then you need different, in order to get it out across sites, you need privacy preserving output gates. And that's what we are working on with this effort, is getting some sort of clear signal, either through AWS or some kind of prompt, right? That it's okay to share full user identity across two sites, right? And then the gates are open, right? Might as well give developers storage and cookies and all that. Once they know the user identity, there's no reason to hold back, right? So giving them a lot of flexibility, again, as long as it's secure, right? Shared storage is really more about, again, writing and then just getting a limited amount of information out, like a small number of bits into a fence frame or something like that. If that makes sense.
Either a limited amount of information out, or I don't know if it is full information, but in a very controlled
right. I think that's the other bit, right? Yeah, you could,
but controlled and limited environment, and that just doesn't work for all use cases. So there has to be an alternative where we have to ask the user or find some other way to say this is okay.
A lot of people get confused about the two names,
yeah.
Shared storage access. I guess we're sorry.
You don't sound very sorry.
Okay. There are no more questions.
It's also the related website sets. If it's served via component updater to the browser, is there some kind of size limitation there?
Ooh, I don't know. Probably. I imagine Chrome component updater doesn't support arbitrary sizes, but I don't think we.
The set size or the overall size?
I guess both.
Oh, there certainly is a limitation for the set size.
Yeah.
That's validated on GitHub and internally in Google. But there can be one primary site, 5 associated sites, and then some unlimited number of service sites, but those are more limited in what they can do.
Is it like I think some websites have more than 5 associated sites. Would they basically have to like do another request on their page or like another permission prompt?
Yeah,
Yeah.
something like that.
Yeah, I would, if they invoked the storage access API, it would just fall back to a permission prompt for them.
I see.
And I mean, I think that's also an important, sorry, everyone, feel free to leave, right, if you have to leave. That's an important mechanism for web interoperability for us, right? Because not every browser wants to support RDBS, they want to make their own choices in that regard, which I think is okay, right? But for them, effectively, you know, Storage Access API from a specification perspective treats that as like, well, there's no set then, or there's, you know, set 0, so they just call it, and then the prompt's shown in the first set member, right? If you're just on a Firefox and you not see the prompt on Chrome because it's like it's an RWS, but you see the prompt.
Thank you.
I think the next one starts in 2 minutes.
Okay. Oh, sorry.
I should get
we
out
have
of
a short
here.
break. All right.
Thank you then.
Thank you, everyone.